IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I'm joined by Eric Mazzoleni, Vice President, Industrial and Embedded IoT Sales Europe at Qualcomm Germany, as he talks to me about their approach in taking away edge AI complexity for their customers and how they enable a wide range of use cases. Hi, Eric. Thank you so much for joining me today. Could you start by giving a quick introduction to who you are and what you do?
Sure. So thanks a lot for your time, Caitlin. I am Eric Mazzoleni. I'm the Vice President for Europe in charge of the industrial and IoT market. So I'm actually based in Munich. I've been in Qualcomm for a year now, and I've been in the semiconductor industry in IoT and industrial for over the last 20 plus years. So a veteran of the industry, if you wish.
Great. And could you also introduce Qualcomm?
Sure. So thanks a lot for your time, Caitlin. I am Eric Mazzoleni. I'm the Vice President for Europe in charge of the industrial and IoT market. So I'm actually based in Munich. I've been in Qualcomm for a year now, and I've been in the semiconductor industry in IoT and industrial for over the last 20 plus years. So a veteran of the industry, if you wish. Sure. So Qualcomm is an amazing company, and we'll talk about the things we're doing in the space of industrial and IoT. Qualcomm, we actually turned 40 this year. We've been celebrating quite a while. We're a technology leader. We've actually been pioneering the mobile innovations for the last 40 years. But we're actually not stopping here. We're actually expanding very fast into new markets where our technologies are super relevant. You can name compute with the new PC powered by our Snapdragon X Elite products, automotive. We're actually delivering, and we've been making some great announcements last week with BMW, for example. We're in XR, so extended reality. And right, we're in and now we're actually as well now investing very fast into the industrial and IoT, which is the topic of this discussion. Our technology footprint scales from, of course, connectivity. This is the DNA of the company, and we're delivering best-in-class and super differentiated technology here at the edge of the market. Now we're as well a very strong leader into low power compute, which goes together with the connectivity. And we're moving very fast into AI, which is really where we see a lot of inflection points in the market and a lot of demand arising from this inflection point for technology. So when you put the three together, compute, connectivity, and AI, this is our strongest value prop. This is what powers our two big brands, Snapdragon, which is really our consumer-centric brand, and Dragonwing, which we announced last year already. That is our B2B brand, and is actually the flagship for everything around industrial and IoT.
Great, thank you for that overview. And you're absolutely right. We will be talking more about IoT, AI, and the convergence. But to frame our conversation and what we'll be talking about today, how would you define intelligence at the edge?
Yeah, that's a big topic. So intelligence at the edge, and I'm gonna try to explain to you as concretely how that works as well in the industry. So there is a big acceleration of the need for processing, right? When you describe the edge is either an end device, or if you take a factory, for example, that would be the edge of the network, right? The edge of the cloud. So you'll have this hierarchy, which is the cloud, and then the near edge, which is where let's say the factory will actually be starting, and then devices, and devices will be the far edge devices. Okay, so what is going on right now is a big acceleration of compute at the edge. We're not talking yet about AI, but compute at the edge. Um, if you look at the normal flow in any device now, more and more intelligence comes in because you have more and more sensors, more and more data, right? More and more perception of the outside world, and you need to take actions based on this perception of the outside world. So this is actually what generates as well the interest now for AI, because when you look at that, you have more and more machine-to-machine interactions, and that's the very first step of machine learning, right? This is where it comes. Machine learning in a concrete use case, if you take a machine that will have predictive maintenance, which is one of the easy use cases, the machine is going to sense specific anomalies, right? Either over temperature or vibrations and so on. And it will be able to identify versus a specific model, a pattern, whether it's actually working in band or out of band. If it works out of band, it's going to be triggering an alert for a technician that will have to come. Okay, so that's really where you see this machine-to-machine interaction thing where you have machine learning coming in and you already start looking into AI for a machine, which is really machine learning. Now you take that to the next step. Gen AI, right? Generative AI. In that same use case, you can have the technician coming to the machine to diagnose the issue, and he will be able to, she will be able to ask the machine directly, whether it's through a picture or through natural language. Hey, machine, what's going on? Tell me what's happening. The machine will actually be able to interpret the data and get an output which will be in the same language to tell him this is the issue, this is the diagnosis, you have to fix it this way, and can even guide the technician for a step-by-step tutorial on how to fix the machine. Okay, so this is really like, it's not science fiction, this is really a use case where you're already moving from machine learning to Gen AI, right? And Gen AI will actually be solving a lot of these use cases. Now, the next step, we're already as well working on that, is machine-to-machine interaction, right? And how do supported by AI, which then becomes really a autonomous workflow, right? So machines being able to interact with machines, or robots, humanoid robots interacting with machines or with human, and being able to adapt to their environment, take actions versus the environment, and not just repeat things that are pre-programmed. So that's actually the next step when AI is going to be coming in and solving a lot of these issues. AI is actually at the core of all these new robotics and humanoid robots. Something actually we strongly believe in, because that's actually then the next step of automation within the factory. So again, you look into the hierarchy, compute, and compute now is actually coming into more and more end devices. Extremely fragmented, by the way, so there's plenty of different compute, but we, from a Snapdragon and Dragonwing perspective, when we look into the industrial space, this is actually what we're working on. And then the next step is enable all the steps of AI from, again, machine to machine, human to machine for autonomous workflows.
No, thank you for providing that use case, because I think it's helpful in sort of just helping people to visualize how AI can work in a way that's not really technical, and I think it's easy to get bogged down in the jargon. So taking that into account, what are the opportunities for the edge AI market as you see it?
Yeah, so this one is a very good one, because and that's actually coming together with the opportunity. The big thing is digital transformation. Okay, everybody talks about it. Concretely, what it means is there's actually a transformation across every single market, every single segment of the industry towards more digitalization, more and together with digitalization, more need for intelligence, right, and more need for artificial intelligence applied to specific digitalization topics. So if I browse through the key trends, it's actually super exciting. And again, this is why our Dragonwing umbrella is actually accelerating very fast. You start with manufacturing. So I described some of these use cases for or process automation or specific machines operation. But this is really the core, right? So from a European perspective, this is actually accelerating very fast. This is actually not just European, by the way. This is a global topic. Uh, Manufacturing, right? You had macroeconomics, by the way, with all the challenging related to the macros, where the reindustrialization of Europe will actually drive a lot of this demand for digitalization together with it. So we believe very, very strongly in there. We see robotics, humanoid as the next big things that will actually as well accelerate the need for AI and accelerate the need for our dragon wing processors. Right? So that's really coming together nicely. Now, the things you'll see more on a personal basis, the energy piece, right? So, huge topic as well. Digitization of the energy, digitization of the grid is going on and accelerating. With that comes much higher need for compute. So, essentially, concentrating a lot of the functions that are hardware functions moving into the software domain. That drives huge upside for the compute opportunities. And with compute and with data, need for AI. So you look at it as the grid, so the core of like the cloud for the energy, right? So the grid, moving to the edge with smart metering into the house, smart homes. How do you then embark the whole ecosystem around your house and the energy across your heating system, your car, local batteries coming in. All these things have a need for interconnection, so they'll need connectivity. All these things have a need for digital communication, and all these things have a need for a smart way to be managed and interact with the grid, therefore the push and the need for edge AI. So this is actually accelerating big time and coming together very fast there as well. If you look into more things, you take a look at retail shops, right? You have more and more a need for a customer experience that is going to be personalized, right? You have more and more the need for live management or active, very fast management of the inventory, making sure that the shelves are already or always full. All these things are actually driving a need for a smart way to manage the shop, a smart way to manage your checkout payment systems, a smart way to, and that's actually where humanoid come in as well there, a smart way to manage your specific shopping floor, make sure that it's never empty, that, you're running out of Coke, the machine's going to get it and put it in. All these things are actually real use cases we're actually actively working on today. And some of them are already deployed, right? Like these self-operated checkout kiosks, for example, that's actually loaded with a lot uh, of course, compute, connectivity, because it connects to the infrastructure, and AI, whether it's for Gen AI communication, natural communication with the end user, or just AI itself in terms of logging the data and looking at two patterns of people buying and all these things. So there's actually a lot of things going on there in this market. That thing actually, by the way, links very quick to the logistics and warehousing, where again, same thing, self-operated vehicles inside the factory, or the logistic or the warehouse hub. Pallets moving with robots. Pallets interacting with each other, right? Or pallet movers interacting with each other so that you don't have collisions. Drones to manage the inventory. All these things are actually happening already today. Again, compute, wireless connectivity, edge AI. I talked quickly about the smart home, but when you expand from the heating, the energy piece into the home itself, right, with your consumer devices, a lot of innovation happening here. Whether you're talking about smart appliances, there was a show a couple of weeks ago where you could actually even see people thinking about robots emptying dishwashers. So that's actually the next step into family peace at home, right? Where you don't have to ask the kids to do it, which generates a lot of friction all the time.
Save so many arguments, so much trouble. Yeah.
So that's actually the next big thing. Well, we already have as well already announced customers putting big screens into the fridge. So the fridge is actually becoming a personal assistant, and you have a lot of interaction with your fridge, not as a fridge, but as a smart device who's able to orchestrate things within the house or the kitchen to give you an easier, better experience when it comes to managing your food or the cooking and everything else. So this is actually happening as well. So again, compute, wireless connectivity for the home ecosystem, and AGI. I talked about robotics, talk about this thing. So you can actually, I mean, at the end of the day, you can expand that to any kind of industrial or machine or device that will either interact with a machine or a user. I didn't talk about smartphones, but that one is obvious where AI, AGI is actually accelerating big time. You don't talk about compute, but computers getting with embedded AI accelerators with a much more personalized and safe experience. And all these things, and we'll talk about it as well, but the concept of AGI will come as well with a strong need for privacy and security, right? And this is actually where all these things come together.
Great. Well, no, thank you. Thank you for that overview. It's obviously a very exciting time because, as you rightly touched upon, AI has so many different applications and so much potential. I wanted to flip that question about opportunities and ask whether you think there are any challenges that need to be addressed that might be prohibiting growth of the market at the moment.
True. This is actually a very interesting one. So, of course, right, we talk about all these things that are happening. There's plenty of investment going on and so on. Where the way we look at it is the key to successful deployment. Okay. And that's actually drives the way we're going to be, and we're already defining our solutions to enable these use cases so that our customers can deploy the use cases as fast as possible, but as well enable them to develop their own way of doing things, not a standard way. So this is actually the biggest thing we're trying to solve right now, working towards solving right now, which is deliver things that are actually enabling each and every single unique business need through a platform, which will be again reusing all these building blocks of compute, wireless connectivity, and AI. Okay, so the complexity is, as I described, right? The market is extremely fragmented. What we're trying to solve is massively complex. So the way we're approaching it, and this is actually again coming up with when you have this thing of complexity, what you want to do is simplify it. Okay, we simplify it by building a complete foundation and building solutions that are tailored for specific use cases. Okay, so if you look into what I was describing as the use cases within the factory, these are actually complete solutions we're already ready to provide. So we've actually deployed that already into field trials. There are public announcements about our cooperation with Aramco, for example, where these technologies are already completely integrated from a use case perspective as a solution for oil and gas leak detection, right? So if you look at it this way, it's going to be simplifying and providing a whole use case already curated with AI optimized models to provide that specific experience. Okay. We are actually expanding under this Dragon Wing umbrella and developing these blueprints for any single vertical, every single industry, providing the most integrated view of a use case and providing a complete solution. So as you can imagine, this is actually very complex to develop, put in place. So that's one thing, right? So our mission, and we already have a lot of these solutions available, is really to look at each and every industry, look at the very specific use cases, and develop that solution. Now we're not stopping here because again, the market is extremely complex and fragmented. So we know for a fact that customers will actually need customization. So we're actually as well providing all the tools to develop and deploy any AI model from any data set or any available model off the shelf, right? So that's as well a way to solve this problem. You enable your customer, you enable the market with the vision and the solution, and as well enable the market with the vision, the solution, and the tools for them to develop it themselves. Um, Through that model, we're actually seeing a huge acceleration already of the need and the pull for AI into these specific end equipments because that is actually the way you make it easy for people to start interacting with this massively complex environment.
You mentioned edge AI models, which is something I think that is worth exploring. So, sticking with this theme of challenges, what technical challenges or what constraints did you experience when you were running and training edge AI models for the solutions you mentioned?
Right. So indeed, this one is again another layer of complexity and another double click into how you actually do it. So at the platform level, of course, the complexity is that AI is going to be using a lot of data, right? And you have to have a lot of compute capabilities inside the device. So that comes, of course, with from a technology viewpoint, ability to integrate all this in a piece of silicon, have the right memory optimization, have the right internal path optimization, so that you can as well manage real-time aspects of any industrial connectivity, industrial communication. So like the baseline thing that make a machine, and include AI into this environment for the best experience. So this is actually from a pure technical viewpoint, like the baseline of how chips are built, and AI has an impact on that. Now, when you look into how you develop a model, the number one thing is, and that's one of the complexity and one of the I would say by far one of the strongest differentiation of the Dragon platform, is have the ability to develop and deploy scalable AI. It's not a one size fits all. It's not a massive processing like we see in the cloud that is going to be generating this pool for edge AI. What you need is a tailored solution, scalable solution, so that you can actually realistically implement a model at the edge within the right power budget and the right user experience. So when I talk about privacy, and I'll come back to that, but you do need as well the right inference time, right? Inference speed, so that the user experience is actually as well seamless, so that the team can actually use AI in real time instead of having to wait and pause for the model to be performing what it's supposed to perform. So all these things actually have to be taken into account. So again, one thing you look into the scalable AI performance. Okay, and our Dragon Wing series, by the way, provide from 100 tops, which is really super high performing, down to 2 tops. So for the most simple edge devices, but together with a very high compute, very low power budget. Now you look into energy efficient computing. Again, that goes back to the core and the DNA of the company, being able to deliver that in the technology node that will allow massive parallel compute together with AI in the best power budget. Again, massively complex, and it's actually one of our key differentiator in the market through the technology we use, as well as, of course, the ability to integrate all these cores in a single piece of silicon. Now comes the how do you actually build and optimize your model? Again, for any company who wants to play in AI, and I'm having these conversations every day. The number one thing is access to data. Okay, a lot of people actually tell you, I don't know what to do with AI, but they have plenty of data that they have, right, and they're not using. So to move this thing to an AI-enabled system, number one is you access the data. Number two, you provide the tools to build a model out of your data. And as Qualcomm, we're actually providing two types of tools. One is called AI Hub, and the other one is called Edge Impulse. AI Hub is our platform where you already have pre-optimized AI models available with sample applications. So any customer can actually go into AI Hub, download the model, compile, optimize for the specific target device. The model will be there, right, with the specific target device from Qualcomm Germany processing, and you run that model. So this is actually super efficient when it comes to rapid prototyping, seamless development. When a customer have a very, very defined user set and data set, and the model is matching, super efficient. So that's already one level of complexity that we remove. Any model is available that is optimized on AI Hub is available to any customer with a specific application set. The next step is actually where the biggest complexity is. I have data. What do I do with the data, right? And how do I develop my model? This is where Gimpulse is providing a huge advantage. Edge Impulse is a platform, something, it's an end-to-end platform that allows you to take data out of your data, you build a model, you optimize your model, you train your model, and you develop and you deploy your model onto the end device. And that is actually across any type of platform, from the super simple to the most complex. That's actually one of the key challenges we're actually looking into solving with the Edge Impulse platform. How do people, uh, how to make it simple, easy for people to actually start to do things with the data they have, knowing that data is actually going to be at the core of all these things in terms of digital transformation. So again, digital transformation means a lot more data is going to be flowing. How do you use the data? And how do you actually optimize things to your specific use case with your specific within your specific environment with your specific parameters? That's actually what Edge Impulse delivers. So when you put the two together, you have the ability to take any model, deploy it, build your own model, deploy it, and run as the most efficiently, of course, on the Dragon Wing processors through a complete scalable set of AI accelerators and compute capabilities so that you can effectively scale that use case, that market across many end devices and many verticals. So that's actually the whole complexity we've been trying to for the last years, and we're accelerating there as well and deploying already to solve a lot of our customers' problems.
I think you raised a few really good points in that. So the first thing around no AI solution will fit every single use case. There has to be some tailoring. One about scalable AI, but also this point about data availability and taking complexity away from customers who have this sense of where do I start? Where do I even begin, even if I have the data that I need? And I think it's a really good question, and it's certainly a point that companies can come up against when they're looking at wanting to use edge AI in the best way. I think one thing we maybe haven't talked about just yet is how to ensure that this data that's being used to train these models is kept secure. So what would you say to that?
So this one is actually, I mean, security and integrity of the data is actually one of the core pillars that drives the need for AGI. So the baseline technology to support the privacy and the security of data is part of what we call our trusted execution environment. It's part of all our Qualcomm processors as a key hardware foundation. So the hardware itself has to be able to provide you the key elements and the key technology to, again, offer a trusted execution environment where you know your data is going to be safe and uncompromised. You take things to secure boots, soft storage security, key provisioning, all these things. We actually have a complete suite to enable that, and that's actually part of our technology foundation. But you're completely right. This is actually the baseline. This is actually the foundation for any kind of, by the way, edge compute, edge AI, any kind of device at the edge will be able to use and perform things on data. So we provide that. That's the base. Now, when it comes to data security and privacy, one of the main challenges is when you look into cloud-based inferencing, and that's actually one of the biggest concerns. If you look into, and I didn't talk about it, but if you look into, for example, the most extreme medical applications for AI, right? If you look into what AI can do in terms of either pure machine learning or Gen AI, in terms of supporting doctors in the diagnostic and so on, this is enormous, huge potential. The challenge with this is taking huge amount of data that are specific to a patient, so have to be secured by default, send that to the cloud. Once it goes to the cloud, you don't know how it's going to be going. You don't know how you control your data. That is driving the need for this edge AI thing, right? AI essentially will be keeping all your data, the trusted data, in your safe environment, in your control environment, within a perimeter that you know is going to be secured end to end. You apply that to the doctor use case. Think about an edge AI box you put into a hospital that will provide the inferencing for all the doctors within this hospital. All the data will actually locally processed and will never leave the hospital. This is super secure. Now, interacting with a model in the cloud is going to be done through a specific inferencing and exchanging critical data for the model to learn as well from all the other doctors in the world, leveraging the cloud, but the local inferencing will be done at the hospital level within this secure environment. Move that to a factory floor. Factories cannot be open for intrusion, right? Because it can just destroy the whole flow. If the factory stops, then you have immense disruption down the line, right, for users and so on. So some factories are not even cloud connected anymore because of that kind of threat. Now you put a on-prem AI box at the factory, on the factory floor to manage all your AI workflow. You can keep it safe, you can keep it secured, and that will actually enable all these things to happen within a control environment. Now, I haven't talked about the impact on, by the way, on power, because cloud AI is using huge amount of power and cost. Edge AI will have some limitations in terms of the compute capabilities, but this is expected. Now it will run very efficiently specific models that are crucial for your environment on a local basis, much lower cost, much lower power. But then you bring, again, on top, everything around security and data integrity. And that's actually where we believe strongly in this AGI acceleration, right? That is one of the key drivers, keeping your data safe and secret and being able to process them from the lowest end edge device processing to super complex, massively multi-processing capabilities on these on-prem AI accelerators. And for that, by the way, we have solutions for this within the Dragonwing umbrella. We scale from processing to what we call our on-prem AI appliance. That is a multi-thousand TOPS box that you install essentially into your premise to your private inferencing.
Sure. So it sounds like you're saying security is perhaps the differentiator between edge AI compared with cloud processing.
that's actually again one of the key drivers for the need for edge specific processing and edge AI processing. Again, on top of cost and speed of inferencing and all these things and efficiency. But this is absolutely a key fundamental piece of the whole equation.
Sure. So, with everything that we've spoken about, Eric, what would be your recommendations for companies who are choosing between whether to build their own edge AI solution or whether they should purchase something that's off the shelf?
Yeah, again, this is one of the key very interesting conversations we're having with our customers, right? What is your need? What is your priority, right? What are your technical requirements? And important as well, what are your time to market goals and imperatives, right? So when you put all these requirements into the balance, the conversation very goes to, okay, so do you know what to do with your data? Uh, how are you going to be using the data? How are you going to build your model? Have you looked into specific models? Do you already have in-house expertise for AI? Because this is actually already quite common, but not as widely spread as you would think. So all these parameters essentially come down to, okay, so if you want something which is, again, based on a specific set of use cases that we've already looked into optimize for, uh, off the shelf is going to be obviously providing a massive advantage when it comes to time to market and R&D investment, right? And this is actually where we're spending our time solving and developing all these curated solutions, so that time to market and fast deployment of the AI at the edge is a reality. So that's number one. Where do you want to go? Now, um, there are use cases, of course, that are massively complicated. There are people who want to develop their own models. There are people who actually, if you take one of the very cool use cases, what you can do with vision processing, right? So vision processing is a big deal. There are huge amount of use cases. Vision processing is actually where AI starts to becoming super relevant, right? So you have a camera, makes acquisition of data, and then once you have the data, what do you do with the data, right? So it goes on the same algorithm. Uh, Customers who want a complete end-to-end solution for camera analytics, integrating Gen AI, will be able to leverage our complete video suite. It's actually called the Intelligent Video Suite. So, for example, that's actually pretty cool. I've actually seen it in action. You have live cameras that will actually record what is happening into a warehouse or an office. And then you have AI models that will be applied onto the data. So the data is actually classified in real time, and it's actually enabled by your processing capabilities, and then fed to the agent. And the agent is going to be able to detect specific events within an office, for example, people falling, or specific intrusion, or track a packet from the incoming of the warehouse or the lobby to the person. All these things that you can do on one camera, multiple cameras, scale that we can actually already today provide as a complete solution. Okay, so again, when you talk about specific time to market, technical requirements, and so on, we have the ability to go into very, very, very complex use cases already with this kind of things. Now, there are people, I don't know, factories or specific warehousing that will want to have their own way of doing things. People already have deployed years of experience into camera processing. Well, these people typically will either use an off-the-shelf model that is already trained for specific AI vision application, or develop. Okay, now they can as well integrate with our platform. So that's actually the beauty when it comes to all this complexity, off the shelf, complete custom, or in between, right? You can actually take your own model, deploy it into our platform so that you leverage the old infrastructure we've already developed. Again, you can just take your data, you may want to make it private, use your tool, you build your model that keeps secret. You do that. You can even expand that with additional algorithmic compute or AI based to complement this use case, and you build your own, right? So um, Concretely, there's no answer, no easy answer to, off the shelf, build your own. It really depends again on what the customers want to achieve. Again, the market being so fragmented, the applications being so fragmented, being so complicated, this is actually our mission. Simplify all that, deliver complete solutions when we can and when there's a use case, build the enablement for everyone to use the data, and have the ability to deploy on, again, secure, safe, all these things that actually we discussed, make it a foundation for edge AI and edge compute uh, for deployment on any Dragon Wing processor. This is our mission.
Big mission, lots at hand, and I think goes back to the point you were making about fragmentation, complexity, and how every solution needs to be tailored to the use case. So I think you've given our listeners a lot to think about. Definitely, a lot of food for thought. So I hope that they leave this with things that they can take away. Before we wrap up for good, Eric, is there anything else you want to mention?
Yeah, I mean, again, thanks a lot for all these questions. I mean, this is really a revolution happening, this digital transformation. The need for compute, low power compute, is there, accelerates, and will prevail, right? That is a foundation. The need for efficient connectivity is actually the baseline of all we do. We talked about security, data integrity. This is actually fundamental to enabling this business. Now, what again we are seeing through this digital transformation is AI, edge AI, is going to be the next challenge, and the thing we're actually already solving, working towards solving for the industry, is massively complicated. We understand that. This is actually where we're investing so much as well into developing these curated suites, solutions, blueprints, and so on. And this is actually what is currently moving Qualcomm. Drive innovation the same way we've been innovating for the last 40 years, creating specific markets on mobile and accelerating our compute and automotive. We're looking at the industrial space as an enormous opportunity for us to be able to solve customer problems, again, around these fundamental technology blocks and enabling widely spread edge AI, scalability, space, so that all this technology enablement will actually solve real world problems and help the customers differentiate on the market and accelerate growth, which is essentially what will drive this business moving forward. So thanks a lot for all these questions and your time.
Great. Well, no, thank you very much for joining me, Eric.
Thank you.
IoT Unplugged.